Okay, so the end of number 37, where we ran out of time, works out to be 34.3016 kilometers per hour. If you did change them to meters per second, this one is 18.68 meters per second. It'll be east, and this one is 9.53 meters per second south. Okay, so they're actually easier because you don't have to do the Pythagorean theorem or anything like that when you get the answer, because they're two separate objects. All right, turn the page to 513, and this one's an explosion one. So you accidentally drop a 3.5 kilogram platter. Before it hits the floor, the motion was entirely in the vertical direction. So it's just trying to say that, like, it hits the floor, and at that point it's going to go out in the x and y, but before that it didn't have any movement in the x and y. Okay? When it hits the floor, it broke into 3 pieces, and they all move out in the plane of the floor. Imagine a coordinate system on the floor. So piece 1 has a mass of 1.3 kilograms, and it moves off with a velocity of 1.8 meters per second, angle of 52 degrees, so counterclockwise. Okay, so this is piece number 1. Tells us it's 1.2 kilograms. Tells us this angle is 52 degrees. And its velocity, v1, and this will be a final, is 1.8 meters per second. Okay, so this is piece number 1. Piece number 2, mass of 1.2 kilograms. Oh, this one was 1.3. 1.2 kilograms, moves off with a velocity of 2.5 meters per second. An angle is 61 degrees clockwise from the negative x, so that would be up here. This angle then is 61 degrees. This is piece 2, 1.2 kilograms. Okay, so this is 2. And its velocity, v2 final, 2.5 meters per second. Find the mass and the velocity of the third piece. So it's going to go down here somehow. It told us the whole platter was 3.5, and there we have 2.5. So m3 must be 1. And we're looking for v3f. Okay? So in the x direction, in the beginning they're all together, so I'm going to save time and write them like this. V initial x will equal m1 v1 final x plus m2 v2 final x plus m3 v3 final x. Initially it goes to 0. Now remember what we said the other day when we were doing this example. You got to be careful of your positives and negatives. v1fx is going positive. v2fx is going in the negative direction. So this will be m1 v1f, and it'll be cos theta 1. And then this one will be minus m2 v2f, also cos theta 2 equal, plus m3 v3fx. Okay, so now you're going to take them to the other side, and their signs are going to flip. So the m2 v2f cos theta 2 will become positive, and the m1 v1f cos theta 1 will become negative, and you're going to divide by m3. So v3fx will equal 1.2 kilograms times 2.5 meters per second times the cos of 61 minus 1.3 kilograms times 1.8 meters per second times the cos of 52, and that's going to be divided by 1 kilogram. And you should get a v3fx to be 0.01378 meters per second. Works out to be positive, which means I did draw it in the right direction, but it's only tiny. So now we can do the y. So again, m1 plus m2 plus m3 will v initial y, and that's just going to go to 0, will equal m1 v1 final y plus m2 v2 final y plus m3 v3 final y. Now if you look in the y direction, both 1 and 2 are going up. They're both going to be positive. So when you take them both over, they're both going to be negative. So I would do them in one step. So M1V1 final, and it's going to be sine theta 1, and when it comes across, it'll be negative, minus M2V2 final sine theta 2 will equal M3V3 final y divided by M3. Okay, so V3 final y will equal negative 1.3 kilograms times 1.8 meters per second times the sine of 52 minus 1.2 kilograms times 2.5 meters per second times the sine of 61, and again divided by 1 kilogram. And you will get a V3 final y to be negative 4.468. And I probably rounded that too much, meters per second. And the negative simply means in the opposite direction to the other two. So if we were to draw this, you're going to actually have a rather big vector this way and keep more than I wrote down here. Okay, it's 4.467 something. And why you need to keep more is because when you square it and square this little 0.01378, if you don't keep more, you won't even notice a difference. So it ends up being 4.46, still 8 meters per second. And the angle, the way I have it drawn here, the angle is going to be tiny. So at an angle of 0.18 or something like that, an angle of 0.18 degrees, and it'll be CCW negative y. If you drew it the other way, the little guy first and then down, it would be 89.82 degrees, and it would be clockwise positive x. Okay? All right, explosions. Flip the page to 515, number 39. So now we're looking at, is it elastic or not? Okay. A billiard ball of mass 1.11155, so this is ball 1, mass 0.155 kilograms, moves with a velocity of 12.5 meters per second towards a stationary billiard ball. Here's mass 2, V1 initial, 12.5 meters per second. 25 is 90, so this is going 45 kilometers per hour. Identical mass, so both masses are 0.55. The first billiard ball moves off at an angle of 29.7 degrees clockwise from the original. So clockwise would be down this way. So this is going to be M1, 29.7. They could have made it 30 and made our life easy. With a velocity, so V1 final, of 9.56 meters per second, which means ball 2 is going to go up this way. You're looking for V2 final theta. You're actually looking to see, is it elastic? But before you can figure out if it's elastic, you have to find V2x. So you need to do your momentum in the x, M1V1 initial x plus M2V2 initial x equal M1V1 final x plus M2V2 final x. 2 is 0, the m's all go, and so you're looking for V2 final x. V2 final x will equal V1 initial minus V1 final, and the x component is cosine theta. Fill in your values. V2 final x is equal to 12.5 meters per second minus 9.56 meters per second times the cos of 29.7. You should get a V2 final x to be 4.196 meters per second. And now go to the y.